I saw a question about confidence intervals.
Yeah.
So when we talk about, I'd say a 95% confidence interval, what we're saying is we have our distribution, we have our mean, our standard deviations, and actually two standard deviations out from the mean is on both sides is the confidence interval. So these, I don't have the, I should have put in the number here, but the confidence interval would be between these two vertical lines. So what it's saying is any value like this blue X here that's within this is within the confidence interval of this distribution. If the red X is outside of the confidence interval, so that's what the confidence intervals are in relation to. And in the example here, we're looking at basically do the confidence intervals overlap? And in this case, there's a very, very small, less than a 5% chance of an overlap here. Whereas in this case, there's actually quite a bit of overlap. See how the distribution here comes down and it like intersects to this distribution here. So in this example, the confidence interval, see the red confidence interval here is overlapping the blue confidence interval here. I hope that helped a little bit. I saw a question too about the alpha of 0.05 and 0.01. The kind of the standard in social science research, which many of us are doing, is 0.05. There may be examples where you need to have a smaller alpha. So it needs to be instead of 5%, maybe 1%. If you're making a medication that would have a very serious side effect, you want to be darn sure. Okay, so it might be in not even 1%, maybe 1/10 of 1% as your alpha. Okay, so it depends on the type of study, but for most of the research that we do, when we're looking at samples and populations, 0.05 is typically what we use. What other questions do we have here?
We had something about the y is 05 the alpha, but I think they were getting confused with p-value. I think people get confused between p-value and alpha level.
Alpha is your decision point. Alpha is your risk of a type 1 error, and beta is your risk of a type 2 error. So if I go back, so this red X here is outside of my confidence interval. It's outside of my alpha. There's still a chance that this is just simply an outlier. Okay, so if I were to reject my null hypothesis, but in fact my null hypothesis is true, that's a type 1 error or an alpha error. And the reverse happens if this blue X was actually inside the confidence interval, but in reality it truly was coming from a different sample, that would be a type 2 error or a beta error. Other questions?
Can you really quick talk about the difference between type 1 and type 2 errors?
Yeah. So a type 1 error, I'm just going to read it. It's the chance or probability that you will reject a null hypothesis that should not have been rejected. So in my example, that's this guy here. That's a type 1 error. Yeah, a type 2 error is the chance or probability that you will not reject the null when it should have been rejected. Okay, and that's this blue guy here. I see a comment, I was disappointed when I didn't find a difference. And again, we're dealing with uncertainty. We're dealing with probabilities. So there sometimes are a lot of reasons why you don't find a difference. One of them can be that it's a type 2 error. It could also be that you don't have a large enough sample size, or again, looking at this, maybe the variation was not accounted for, and there was just a much wider variation than you had thought would be true.
Oh, Pat, really quick, I don't know, what is the difference between standard deviation and variation?
Yeah,
someone wrote that in.
I mean, they're really the same. Right. There's variance and there's standard deviation. Basically, they refer to the same thing, which is how much of a scatter and spread are there in the data around the mean. So is it wide like this one or skinny or like this one.
And also, too, isn't the standard deviations like there's certain percentage away from the mean? Like a 1 standard deviation is so much percent, a 2 standard
Yeah,
deviation is like that. That's by the normal curve.
if it's a normal distribution, then 1 standard deviation above and below the mean represents 68% of the scores. And 2
Okay,
standard deviations represent 95% of the scores.
great.
And so that's why the confidence interval is an important concept, because if you're looking at, something that's greater than 2 standard deviations, then it's likely to be beyond your 95% confidence interval. Those of you in business, if you do 6 sigma, the sigma is the symbol for the standard deviation. So that means that the value is out 6 standard deviations away from the mean. So it's a process for reducing errors or variation in a sample.
So another question is, does the confidence interval add to the reliability of the study? Not the reliability per se, but
No, because every study, every
significance.
distribution will have a confidence interval. So it's a
Right.
matter of all distributions have a confidence interval. Okay, so what matters is if you're testing 2 groups, are they like this, or is there no overlap? And the decision rule on a confidence interval, if you're doing this is comparing 2 separate means. If you're comparing a difference, and if you're doing a difference, then obviously 0, quite definitively no difference. And so when you're looking at a confidence interval, and you have, if 0 is in the range, and the only way 0 can be in the range is if the lower number is a negative number and the upper number is a positive number. If 0 is in the range, then there's no difference. If 0 is not in the range, because either you have 2 negative numbers or 2 positive numbers, then there is a difference, and you would reject your null. I see a comment about skewed distributions. Keep in mind, in many stats tests, a normal distribution is an assumption. That's why it is so important to know that you have a normal distribution. And if you don't have a normal distribution, you've either accounted for it by having a larger sample size or using a non-parametric test, because the normal distribution is what this whole thing is based upon. So if it truly isn't a normal distribution, then you're going to have possibly an invalid test.